Okay, good morning and good afternoon, everyone. Thank you for joining us today. This webinar will be on Actian Avalanche Cloud Data Warehouse with the Google Kubernetes engine. A couple of housekeeping tips. We will be taking questions throughout the session. Please use the Q&A box. This session will be recorded, and feel free to interact with us via the Q&A box. I'd like to introduce Emma McGrattan, our Senior VP of Engineering, to kick off this webcast.
Great, thanks, Vivian. So my name is Emma McGrattan, and as Vivian said, I'm Senior Vice President for Engineering here at Actin. I lead a team of almost 200 engineers located around the globe. Today, we're going to focus on Actin's Cloud Data Warehousing platform, and I'm joined today by Maruti C. Maruti is Technical Architect on the Google Cloud side of things, and he's been a great supporter of the work that we're doing on Google Cloud, and provided a lot of guidance on how best to leverage Google technologies like GKE, and I'm delighted to have him join me today for the webinar. He's going to dive into some of the best practices Google recommends for deploying complex technologies like we've done with Actian Avalanche, and we're going to have an interactive chat about some of the technologies that Google provides. So for those of you not familiar with Actin, we've been around for quite some time. We've been in the data space for over 30 years. We have three primary product lines. We've got our hybrid cloud data warehouse, we've got our mission critical data management technologies, and then our enterprise data integration technology. So three separate product lines, but they're all converging into our Avalanche data platform. We're really focused on performance, and we consistently deliver on the best performance on commodity hardware. And when you think about cloud, it's nothing but commodity hardware, but delivered at elastic scale. We have over 50 patents in the portfolio, and we're constantly increasing the number of patents. We've got some really clever engineers in my team, and they've got some really great innovations that they're delivering upon. While we're not a household name, we are in 24 of the Fortune 100, and we've got over 3,000 customers globally. We're 80% owned by HCL, and HCL is bringing us into many of their large accounts. So that number you'll see increasing all of the time. Across the bottom of the screen, you'll see some logos from some of the customers that we have in the Actian customer base. If you visit the website, you can read quite interesting stories about what our customers are doing with our technologies. But if I start with the one all the way over to the left here, the University of Oxford, our data technologies, including the analytics technology we're going to talk about today, is used in the Clinical Trial Services Unit at Oxford University. And those of you that have been paying attention to the AstraZeneca COVID vaccine trial, that's all being, that data, I should say, is being analyzed using Actian technologies. All the way to the other end of the scale is the AA, and that's the Automobile Association in the UK, and they're using the Actian Avalanche platform for providing quotes to customers that come onto their website that are looking for car insurance and home insurance. And what they do is they collect the information like your name and address, date of birth, and the details of your car. They then augment that data and they come up with a quote, their target time being less than 2 seconds to generate that quote. And that needs to be a quote that their underwriters can stand behind. So, when you provide the VIN for your car, they've got to go off and make sure, what has it been in any accidents? Do you have a long history of speeding tickets on your record, and so on? So all of that is done using the Avalanche platform that we're going to talk about in greater detail today. So we're going to do first off is to provide an overview of the platform. So before diving into technology, I figured it was a good idea to share with you at a high level what it is that the platform does and how it's constructed. Then we're going to switch over to Maruti, and he's going to talk about Google Cloud technologies, and together we'll talk about how Actin's been able to leverage Google Cloud technologies to deliver upon what we have. And then we're going to do a demonstration. So the demonstration will show you how easy it is to deploy Actian Avalanche, how you can leverage the built-in integration capabilities that are part of the platform, and then how simple it is to use Looker, and how with Actian Avalanche you can get a real-time view into your data using Looker. So at a very high level, you could think of Actian Avalanche as being this hybrid cloud data platform. It's running on GKE. To the left-hand side, we've got Google Cloud Storage, because that's where all of the data assets that the warehouse is going to be storing are going to live. And we can also integrate with Google Dataproc. So if you have a data lake that you're using with Google Dataproc, we have the ability to reach into that data source and to pull the data from there and make it part of your data ecosystem. So that might be that you want to reference it as an external table within your warehouse, and certainly you can do that. Or it may be that you want to import data from Google Dataproc into Avalanche. Sitting below the bubble that represents Avalanche is the fact that we're using Google Cloud Identity. So we're using Google SSO. So if you choose to use that mechanism, it makes life very simple. And then to the right-hand side, just indicative of the fact that Avalanche is available today in the Google Cloud Marketplace. So if you're interested, we'd love for you to sign up for a trial and to try it with your data and with your queries. To the right-hand side are just two of the Google technologies that we are integrated with, Looker, which I'll provide a demonstration for today, as well as Kubeflow. And our intent is that we will provide integration with all of the Google technologies that are part of the Google platform. So at its heart, we've got the data warehouse, and that's what we're really focused on today. But we have extended it to include data integration capabilities. So let's talk a little bit about it. So we've delivered Actian Avalanche to deliver unrivaled performance. And I think every vendor out there is going to tell you that they have a highly performant platform and that they can beat everybody else. And we've actually engaged the services of a third party to validate our performance claims. We also use that same third party to validate our cost claims, because we believe that we've got the best price performance metric that you'll find. We've delivered this platform for hybrid deployment because not everybody's ready to move lock, stock, and barrel to the cloud today. What we think makes sense is that as you move on a journey to the cloud, that you move those workloads that are best suited to the cloud, you get comfortable with cloud deployment of your analytics, and then you can move more workloads over. We've included our native data integration capabilities as part of the platform, and we're really focused on the operational analytics use case. And what I mean by operational analytics is that as your business is transacting, you want to be able to see the results of those transactions in real time. So let's dive a little further into the details here. So with respect to the performance claim, what you'll see on the right-hand side of this graph, of this slide, is a graph representing the time it took in seconds to execute a TPCH, so that's a industry standard decision support benchmark, over 30 terabytes of data with 5 concurrent users. So what you'll see represented in the graph is the number of seconds it took to complete the queries. The number for Avalanche was just over 2,000 seconds. And for Snowflake, which we encounter in pretty much every opportunity we go into, that number is closer to 17,500 seconds. So you'll see is, we're significantly faster. These results were actually produced by a third party called GigaOM. And if you're interested in learning more about this benchmark and exactly how it was set up, the exact configurations for each of the technologies, we'd love for you to visit the Actian.com website, where you can download a copy of the report, or if you want to send me an email at emma@actian.com, I'd be delighted to share a copy with you. So really focused on performance, and what you see here is that we're 8 times faster than Snowflake. We've also designed Avalanche to support large numbers of concurrent users. So with this test, we just ran 5 users, and that was, to be fair to Snowflake, they have an architecture that spins up additional compute clusters as you add each group of up to 8 users into the scenario. And we thought we'd keep this simple, right? We'll show you with 30 terabytes and just 5 users, the benefits you can get. These benefits increase as you increase data volumes and the number of users. Now, the cost for completing that benchmark is reflected in this graph. And what you'll see is for Avalanche, it was $145. And for Snowflake, it was over $930. So it's not like, to get these performance numbers from the first slide, we had a super, souped up environment for Avalanche, and we had, crunched Snowflake down into a tiny configuration. And you'll actually see that we're much more cost effective. So not only are you getting the best performance, but you're getting incredible value for money here, coming out at 6.4 times more cost effective than Snowflake does. And as I said earlier, that cost benefit increases as you bring more users into the environment. Now, while Google Cloud is really important to us, both in terms of the partnership, but also in terms of a platform that can really help us deliver superlative performance, we do also have support for AWS and for Microsoft Azure. And because of the way we're leveraging Kubernetes, we will later this year be providing an offering whereby we'll have the ability to support a VPC configuration. So just a little bit more detail on that. So the way Avalanche is deployed today, we've got our management plane and our data plane. And the management plane is where you'll conduct tasks like create a warehouse, back it up, and so on. And the data plane is where your data assets live. So that's the actual, the warehouses, the data integration jobs that you've defined. And today, Avalanche Cloud Actin manages all of that, right? And then can be deployed in the cloud of your choosing. Later this year, our intent is to deliver on a managed VPC. And in this scenario, what we'll be able to do, leveraging Kubernetes, is to push that data plane into the customer managed environment. So this may be that you're a large financial services institution, you've got your part of the Google Cloud carved out, and you want your data assets to be resident within your virtual private cloud within the Google Cloud. And this is going to be enabled using Anthos and Google Kubernetes, and something that we'll deliver later this year. We believe that in financial services and in healthcare, this could be quite interesting. And then early next year, the plan is to deliver on a customer managed VPC. And in this configuration, we'll be pushing both the management plane and the data plane into the customer's environment. And where this could be interesting is in scenarios where you've got data sovereignty requirements. Maybe you're sitting in UAE and you want to make sure that your data assets and everything that touches them is resident in country. This customer managed VPC gives us the ability to support that. Now, where we say here that this is the customer managed, of course, this could be your favorite systems integrator that's doing that management. Like it could be that HCL is providing this as a service to their customers. So you'll see us leveraging the technology that we're talking about today to support these different deployment configurations that will allow us to meet very specific security needs of our customers. The native integration capabilities is provided by Avalanche Connect, and that's our data connectivity or data integration capabilities provided as part of the platform. Gives you the ability to reach into data lakes. Maybe you've got a Parquet file that's sitting on S3, you want to get in there, pull that data into the warehouse. Avalanche Connect, which is provided as part of the platform, enables you to do that. So we've a bunch of different connectors. In fact, there's over 200 connectors in the portfolio, including the ability to connect to SaaS applications, on-premise applications, to your own custom applications using our REST API. Maybe you're using Kafka for streaming. All of this is provided for as part of Avalanche Connect. Also, as part of the warehouse, we have an external tables capability delivered via Spark, which gives you the ability to register a file that's sitting in a data lake as a table within the warehouse. And then as you reference that file, we'll do query pushdown, get the elements of the file that you want to solve this particular query, and you'll have the ability to join that with native warehouse data. So this is a mechanism that we've seen a lot of people use for loading data into the warehouse using our external tables capability. While we provide all of this as part of the platform, we recognize the fact that many of our customers and prospects have already made investment in technologies like Informatica and DataStage, and they want the ability to run those jobs, but to change the endpoint from something like Netezza to the Avalanche Hybrid Cloud Data Warehouse. So we have a native connector that allows you to do exactly that. Our partner for change data capture is HVR, and on the right-hand side here, what you'll see represented are the two user communities that we're best suited to. The first would be the business analyst community, and they'll be using tools like Looker and Tableau and Power BI to drill into the data and to do some ad hoc querying on their own. And then the data ecosystem user, your data scientists and your data engineers are provided for tools like Jupyter Notebooks and Python, Spark SQL, and so on. And then finally, the best use case for Avalanche is this real-time use case, because we have this amazing capability to provide support for updating transactions to be committed to the database in real time. So as you're, maybe you're using let's say it's Oracle financials, and you want to feed that data in real time into the warehouse. As you're transacting your business, you can use the change data capture capability to feed those changes into the warehouse. And then as you're reporting on it, maybe you're coming into the last few days of the quarter, and every couple of minutes you want to see, or even up to the second, you want to see how's the business doing. You have the ability to do that with a combination of Looker with Actian Avalanche. So how have we achieved all of this? So this is at a very high level, the Avalanche architecture. And what I wanted to point out here is our usage of GKE cluster. So the warehouse itself is composed of a leader node with a bunch of worker nodes that are sitting in pods inside our GKE cluster. We also have a smaller node pool for things like our query editor, and you'll see that when we get to the demonstration. And then we provide support for tools like Looker and Tableau and Power BI. And to the left-hand side, what you'll see is that for the data warehouse data, it's all sitting in Google Cloud Storage, and then for some of the metadata for the instance, we're using some provision storage. So this is a very high-level architecture, but I thought it was good to kind of set the stage and why we think this conversation around GKE may be interesting to you. So at this point, I'm going to transfer it over to my friend Marudi from Google, and I believe I'm going to stop sharing, and you should be able to start sharing now.
Thanks, Emma.
Sure.
Okay. Can you confirm if you're able to see my screen, Emma?
Yes, yeah, I can see it. Thank you.
Awesome. Hey all, thanks for joining today. I'm Maruti. As Emma mentioned, I've been working with Actian for the last couple of months, helping them with the best practices on GCP and especially GKE. So in this session, we'll be talking about some of the best practices that Actian team followed and implemented to run cost-optimized workloads on GKE and to avoid over-provisioning of the nodes. Eventually, also avoid other instability issues. So, and not just for Actian, if you're planning to deploy any of your SaaS or PaaS applications, these best practices will definitely help you to design your applications. So this is the agenda. In the next few minutes, I'll be talking about the auto-scaling options that are available in terms of workload auto-scaling and infrastructure auto-scaling, and why choosing the right mission type and the appropriate region can actually help you save in terms of cost savings, and some of the pointers in terms of how you should be thinking about logging and monitoring strategies, which are often overlooked, and how do you design your application in terms of high availability, whether you should design your application as a single zone application or multi-zone or regional. And then at the end, we'll kind of touch base very high level on the different workloads that you will be dealing, and how do you prepare your environments to fit those workloads. So auto-scaling is a strategy GKE uses to help Google Cloud customers pay for what they need by minimizing the infrastructure uptime, which means making workloads and their underlying infrastructure start before demand increases and shutting down them when the demand decreases, right? So in Kubernetes or in GKE, your workloads are containerized application that runs inside the pods and the underlying infrastructure, which are set of nodes. That the nodes are what are responsible for providing the computing capacity to run the workloads. The workload and infrastructure can scale horizontally by adding and removing pods or nodes, and they can scale vertically by increasing or decreasing the pod or node sizes. So these are the features that help with the auto scaling the pods and nodes in terms of increasing, decreasing nodes, or scaling up and scaling down of your pods. So in the next few minutes, I'll touch base on each of these auto scaling options, and also some things that you may want to consider when you are designing your applications. So horizontal pod autoscaler, or HPA, is for adding and removing pods based on utilization metrics. Here you can use custom metrics like requests per second, or the standard metrics like CPU or memory. HPA adds and deletes pod replicas, and it's best suited for stateless workers that can spin up quickly to react, let's say, any spike in the traffic, and can shut down gracefully to avoid workload instability. So the main thing to focus when they are configuring HPA is your buffer size, right? So a small buffer can prevent early scale-ups. For example, if you set, let's say, 10% of your buffer, you don't need to scale up early, but it can overload your application during spikes. And if you want to, let's say, configure a large buffer, like 30% or 40%, then you're actually allocating a lot of resources, and it kind of increases your overall cost. So there is no a standard number or standard configuration, guidelines or checklist that you can follow, but the exact target is application specific. And you must consider the buffer size to be to be enough to handle requests for, let's say, 2 or 3 minutes during a spike. And the next one is the vertical pod autoscaler. Again, this is an autoscaler for dealing with the pods, and not in terms of horizontal, but this is like vertical. If your pod resources are too small, your application can be either throttle, or it can lead to out of memory issues. If it is too big, you have a lot of resources waste, and consequently leads to bigger bills. VPA is meant for both stateful and stateless workloads. And this is more useful when you don't know the proper pod resource requests. And there are multiple modes that are available when configuring VPA. Off, which is you can configure the VPA in the off mode. But again, the advantage here is it kind of generates you recommendations. And then initial is when VPA can help you configure the resource requests at the start of the pod, but not it doesn't support the pod entire life cycle. Whereas auto supports at the beginning of the pod start and also during your pod life cycle. So, and one thing to note here is VPA does not generate recommendations based on sudden increase in resource usage. It is more useful, and it only provides you stable recommendations over a longer period. For sudden requests or sudden spikes, like we discussed in the previous slide, HPA or the horizontal pod autoscaler is the right mechanism, or the right autoscaler mechanism. And if you plan to use VPA, the best practice is to start with the recommendation mode, and only when you feel comfortable and with the enough testings, you may want to either switch to initial or auto mode. And when you auto is easy, right? Because again, you don't need to keep monitoring, and it takes care of scaling up vertically. But there are two other important aspects you may want to consider when using auto. So make sure your application can be restarted, because what the VPA does is when it needs to scale up the pod, it actually terminates and creates a new pod with a new set of resource requests like CPU or memory, right? And also set the pod disruption budget. Pod disruption budget is to tell the VPA how many nodes are pods, so how many pods it can kill at the same time, because you definitely need some pods to serve the traffic. And also try to set the minimum and maximum container size to avoid VPA making significant changes when your app is not receiving traffic, right? So if you don't have minimum, so VPA can see that there's no traffic and there's underutilized, and then it tries to decrease the size of the pod. So it's better to set the minimum. That way, VPA doesn't tear it down and it causes disruption to your traffic. So the confusion is which one to use, VPA, HPA, or VPA, horizontal or vertical pod autoscalers, right? Both the HPA and VPA serve different purposes, and one can be more useful than the other depending on your application's requirement. The official recommendation is not to use mix HPA VPA on either CPU or memory. However, you can use them by running your VPA on recommendation mode and use a HPA on either system metrics, standard metrics, or custom metrics. Or you can use VPA in recommendation mode and then use HPA and the metrics. There's also a new feature called multi-dimensional pod autoscaling, which allows you to do use horizontal scaling based on CPU and vertical scaling based on memory at the same time. There's a beta feature. This is newly launched. If you have this kind of use case and if you're interested in exploring, please do check out the public documentation, Google documentation. And also there's one other limitation with the VPA right now is it cannot be used with JVM based workloads due to the limited visibility into actual memory of the workload. So in these cases, if you have JVM based workloads, you can still use the HPA to scale up your pods. And so far we talked about autoscalers with respect to workloads. Now, cluster autoscaler deals with the infrastructure related scaling. It is best practice. It is a best practice to enable CA or the cluster autoscaler when you're using either HPA or VPA. This ensures if your pod autoscaler determines that you need more capacity, the underlying infrastructure grows accordingly. So what CA does is it automatically resizes the underlying computer infrastructure. CA provides nodes for pods that don't have place to run in the cluster and remove underutilized nodes. So you can see the diagram where the first one talks about if you have pods to be scheduled, and if there are no underlying infrastructure, the CA automatically spins up new nodes. And in the below visualization, you can see that if there are underutilized nodes, it tries to delete them or remove the underutilized nodes. And also the other important point is CA is optimized for the cost of infrastructure. So which means if there are, let's say in a cluster, if there are 2 or more nodes and CA different node types, what cluster autoscaler does is it chooses the least expensive one that fits the given demand. For example, let's say we have a preemptable VMs and standard VMs. So it tries to consider the preemptable VMs because they are least expensive, and CA is intelligent in terms of choosing the least expensive. And also when configuring cluster autoscaler, you need to understand that there are certain pods that cannot be restarted by any autoscaler. For example, kube system pods, right? So when you set up or create a cluster, Kubernetes cluster, there are kube system pods like kube DNS and metric servers. And there are also this cannot apply to the pods which uses the local storage, for example. So, but there are ways to overcome that, where you need to set additional configuration. And for kube system pods, what you can do is you can override the behavior by defining the pod disruption budget, and also for the pods which use local storage, you can set an annotation, which is the safe to evict annotation that can, that can let cluster autoscaler take care or, restart the pods when needed. And also, if your workloads are resilient to node restarting unintentionally and are okay to lose session or capacity, then you can save a lot of money by creating your cluster with preemptable VMs. So we'll talk more about preemptable VMs in the next few minutes, but that can definitely save in terms of a lot of cost savings. And the another feature or the autoscaler with respect to the infrastructure is the node AutoProvisioning, NAP. And this is an extension, you can call it as an extension of cluster autoscaler, which automatically adds new node pools in addition to managing their size on the user's behalf, right? So cluster autoscaler creates you nodes, whereas the node AutoProvisioning can actually create node pools as well. So with node AutoProvisioning, GKE creates and deletes node auto pools, node pools automatically. Good practice is it's a good practice to use node AutoProvisioning with VPA, right? Because that way GKE you are allowing GKE to efficiently scale your cluster both from pods point of view and also nodes point of view. VPA automatically VPA, the vertical pod autoscaler, sets values for CPU, memory requests, and limits for your containers, and the node AutoProvisioning automatically manages node pools and removes the default constraint of starting new nodes only from the set of user defined, allocated created node pools. When using horizontal port autoscaler for serving workloads. So again, there are different kinds of workloads like batch workloads and serving workloads. So you can call serving workloads as workloads that needs to respond right away to the requests, right? Customer or client requests. So when you use horizontal pod autoscaler for your pods, considering reserve a larger target utilization buffer, because NAP is more advanced and it actually introduces some latencies in some cases. Further, again, if pending pods, let's say the pending pods that needs to be scheduled have workload separation constraints, right? So let's say if they have any affinities or tolerations, right? If they need to be deployed or associated with a set of nodes, node auto provisioning can provide nodes with matching labels and taints. Node auto provisioning can create nodes that satisfy the constraints. So what when there are pods to be scheduled, and if there are any affinities that they have to be bound or to be deployed on a specific set of nodes, and also taints, which means the pods cannot be deployed on a specific nodes. So the auto provisioning can adopt to those constraints. And also, just like the cluster autoscaler, if you have a right use case and if the workloads are okay to be shut down or brought down unintentionally, preemptable VMs can help you save a lot of money. So now we have lots of options in terms of workload autoscaling and infrastructure autoscaling. The question is, which one is the right for my application, and then which one should be configured for different applications, right? So no one configuration fits all possible scenarios. So you must fine tune the settings for your workload to ensure autoscalers respond correctly to increase in traffic. Scale up might take time due to infrastructure provisioning, right? So you can see on the right side that it talks about a specific scenario with respect to workload scale up scenarios. So let's say if a pod is being deployed on a node for the first time, it has to download container images and then start up. But let's say if it needs to create the workload autoscaler, HPA or VPA needs to create pod replicas, it's more faster. The same applies to the infrastructure scale-up scenarios as well, right? So if it is CA, it's a little faster when compared to the node pool auto provisioning, because node pool auto provisioning has to provision node pools as well, right? So there's no one configuration fits all. So you may and the whole point of auto scaling is to avoid over provisioning, but at the same time, the infrastructure provisioning can actually add some latency. So the best idea is to provision over provision. Don't squeeze your cluster, but just over provisioning that is required for buffer. That is required to handle expected peak requests during scale-ups. And there are some guidelines on how do you come up with this, let's say, HPA utilization target. So this equation you see can actually help you derive the right number. So here you can see if an example could be that if you expect a growth of 30% in your requests in the next couple of minutes, and you want to avoid reaching 100% of CPU by avoid reaching 100% of CPU. So what you can by defining a 10% safety buffer, let's say. So your formula will look like this, and the one minus buffer by 1+%, and then it gives you the HPA utilization target. And the other way to handle spikes is using pause pods. So pause pods, again, what they do is so the reason why you need pause pods is cluster autoscaler reacts to or responds to the pod scheduling request. So you cannot actually spin up nodes upfront. So, but what pause pods can help is what they can do is they are very low priority deployments, but they do nothing but reserve space in your cluster. That way, when a high priority pod needs to be scheduled, what the CA or the cluster autoscaler or the NEAP does is it actually evicts the pause pods and creates room for the new pods. So again, it's a best practice to have one let's say single pause pod per node. So far we discussed about the auto scaling options, but beyond auto scaling, other options can also help you run cost optimized applications on GKE. And one of them is to do with choosing the right machine type. So preemptable VMs, again, we talked about preemptable VMs when we talked about cluster autoscaler and the node AutoProvisioning, right? So these are nothing but compute VM instances that last a maximum of 24 hours and provide no available guarantees. So if you use them wisely, they can actually help you. They are like help you save lots of cost savings, and they're up to 80% cheaper than standard compute VMs. And PVMs are best suited for running batch or fault-tolerant jobs, right? Because they are less sensitive to the non-guaranteed nature of PVMs. You can think of so image processing or any kind of batch processing. And if you really want to, let's say, use PVMs for, let's say, serving workloads or stateful workloads because they are cheaper, but you'll run or kind of come across these constraints. And as long as you can take care of those constraints, then definitely you can use your workload with PVMs. And the constraints are pod disruption budget may not be respected. So we talked about pod disruption budget, where how many nodes can be brought at any point, how many pods can be brought at any point of time. And now this pod disruption budget will not be honored when using PVMs. And also node preemption ignores the pod grace period, right? So when you don't want to abruptly bring down your pods because let's say they need to do some take care of in-flight requests, for example, right? And that is where you configure terminate pod grace period, right? So what happens is when the node preemption happens, it doesn't honor the pod grace period and can actually cause some errors to the client calls or customer calls. And also it may take several minutes for GK to detect the node was preempted. So again, it can lead to some errors from client calls, or your load balancer might not detect that these particular pods are not available. But again, there are ways to overcome and handle the scenarios. So one of them is the node termination event handler. It's an adapter for actually translating compute engine node termination events to graceful pod termination. It's a open source code, not managed by Google, but many of our customers use that. But this is again a story before 1.2. If you're running on Kubernetes version 1.2, because with the Kubernetes 1.2 or later, there's a new beta feature. Again, it's still in beta, which is the kubelet graceful node shutdown feature. So what it does is the kubelet attempts to detect the node system shutdown and terminates pods running that node. So the kubelet is responsible or ensures that the pod follows the normal, either standard pod termination process. So depending on the version of you're running Kubernetes, you can actually use one of the options here to overcome the constraints. If you're planning to, if you want to use serving workloads or stateful workloads to run on PVMs, eventually where you can save lots of resources and help with your cost optimization. Finally, PVMs have no guaranteed availability, which means they can stock out easily in some regions. So to overcome this, what you can do is you can set a backup node pool without PVMs. So Autoscaler gives, again, as we talked about this, it's designed for cost optimization. So what it does is it gives preference to PVMs because, that's how it's designed. So it gives importance for PVMs. And if you don't have PVMs, then you can use the backup node pools, which you already kind of provision. And the next type of machine type that you can actually save a lot of money is the E2 machine types. They're cost optimized VMs. how they differ with respect to the standard or other CPU optimized or memory optimized is that these mission types offer you sizing anywhere between 2 to 32 vCPUs and 0.5 to 8 GB of memory per vCPU. And these are available on a set of standard CPU platforms. And if you are okay with the set of standard CPU platforms, and let's say for your non-production environments, for example, where you don't need huge vCPU values, so E2 can be easily considered. And on average, they can actually save up to 31% when compared to the standard N1 nodes, N1 machine types. And this can be launched as preemptable VMs as well, right? So all the machine types can be actually launched as preemptable VMs as long as you're okay with them being shut down or brought down abruptly, in like 24 hours. And these machine types are also suitable for, let's say, web servers, microservices, business critical applications, and small to medium databases and development environments. So also small to medium workloads that require at most 32 vCPU, because that's the key. They can only support 32 vCPUs. And also that does not require local SSDs or GPUs are ideal fit for E2 machines.
Maruti, we are running short on time. I just wanted to give you a time check.
Okay, I'll skim through this real quick. Okay, the next set of slides. So again, selecting the appropriate region can also help you save lots of money. For example, running on compute prices in US can be 30 to 40% cheaper than SAO. And if your workloads require, let's say, copying data from one region to other, as a batch job, you must also consider moving this data. So there are some examples and lots of best practices that are available in our documentation. So feel free to refer them for when you decide which region to choose. And also right now, as we speak, there are 25 GCP regions available. And one of the overlooked strategies or places where you can cost optimizes the logging and monitoring strategies. So if you use cloud logging and cloud monitoring, the Stack driver, for example, previously it used to be called Stack driver, which to provide observability into your applications, you're only paying for what you use because they are managed services. You don't need to deal with running them or spinning them. They're all you're just paying for what you use. But again, the price also depends on the size of the logs you store. So you may want to design your strategy in a way how much logs you want, that way you don't end up paying huge prices. And also there's a pricing calculator on our website as well that can actually estimate or can help you decide how much cost you'll end up paying for these logging and monitoring tools. So when you try to use a pricing calculator, the product type that you want to select is a cloud operations. And you may also want to implement some cost controls that can help with cost savings. For example, let's say as part of logging, you can exclude logs that are not relevant, right? For example, you can exclude, let's say, load balancer logs, and you can exclude HTTP 200 OK because that's not successful. You may want to focus more on error and failed calls. And also from monitoring point of view, you may want to limit the number of labels on VM as that can generate, let's say, huge volume of time series. There are other bunch of best practices. I would highly recommend you check out the documentation, best practices documentation on our public documentation. So again, there are multiple ways you can create GKE cluster, right? Single zone, multi-zonal, and regional. And because of the high availability of multi-zonal and regional, normally, production environments are spin up using multi-zonal and regional. But again, as these workloads to talk to each other, there's an egress traffic between, is generated, and there's price with this egress charge. So the best way is to keep monitoring using the GKE usage metering. So there's a GKE usage metering that can not just show you insights into the egress traffic, but also can help with few other GKE cluster related things as well. So I highly recommend using this. That way it can also help you decide, let's say, which team is using the most kind of things. And for non-production environments, best practices for cost savings to use single zone. And also consider using interpod affinity and anti-affinity configurations to co-locate dependent pods from different services in the same pods and in the same availability zone to minimize costs and network latency. So these are all pod related configurations where you can say what nodes they can reside on or can be deployed on. And so again, there are different kinds of workloads, batch and serving workloads. So enterprises have different costs and availability requirements, and serving workloads require a small scale-up latency. Batch workloads require are more tolerant to latency, right? Because these are workloads that are being processed in the background, or these are for, let's say, these are let's say tolerant jobs. So the first recommendation is to separate batch workloads in different node pools. That way, the cluster autoscaler can delete empty nodes faster when it doesn't need to restart pods. So the second recommended practice is to use node auto provisioning to automatically create dedicated node pools for jobs with a matching taint or tolerance. That way you can separate many different workloads without having to set up those different workloads. And so again, serving workloads must respond as quickly as possible to bursts or spikes, like let's say Black Friday or any peak seasons. And your application must prepare to handle them. So in addition to dealing with the best practices with respect to workloads and infrastructure, you need to configure your applications to run effectively on Kubernetes. So right now we're not deep diving into those options, application related best practices. But if you're interested in knowing more, please feel free to leave a comment or reach out to the Actian team. Thank you. Emma, over to you.
Great, thanks, Maruti. That was a lot, and it seems like, based on the interactions that we saw from customers, that they really got a lot out of it. So thank you for that. In terms of what Actian Avalanche gets out of GKE, there's a whole bunch of benefits that we derive from the use of GKE for deployment. So the first is it's taken our deployment time down from over 30 minutes for large clusters down to about 4 or 5 minutes, and it's consistent. For very small and for our larger clusters, we're really happy to see this deployment time shrink quite considerably, because we want people to get excited about it and to start using it, right? And not wait half an hour or an hour while the cluster gets created. And it also gives us the ability to leverage the rolling update stream. So if we have new product features coming out, if we have new fixes coming out to any of the components that make up the technology infrastructure, we can roll them out via the update stream and keep everything up to date. Because we have a separated storage and compute, we have the ability to infinitely scale the storage as well as scaling the compute resources. So if you're coming up to end of quarter, as we are right now, and you want to add in additional resources because you've got a much heavier load on the system, you have the ability to scale those resources as you need it, and then to scale back down when that peak or when that surge has passed. We also love the fact that it provides us with, from an infrastructure perspective, some level of robustness, like self-healing. We're loving the network infrastructure. We feel like it's about 30% faster than our other cloud platforms, and we're going to measure that. Later this year, you'll see a new benchmark report showing some new numbers with some new benchmarks run on Google Cloud Platform. And it gives us a level of portability that we didn't have previously. So a ton of benefits to be derived from our use of GKE. And I really appreciate Maruti taking the time today to share with you some of the best practices coming in from the Google side. At this point, I was going to switch over to a very brief demonstration. I realize we're tight on time, but if you bear with me for just 5 minutes, I'll give you a whirlwind tour of the Avalanche platform. So when you come into Avalanche, first of all, you'll see a list of warehouses. Well, as a new customer, this list will probably be empty. But when I came in here, I saw that we had a couple of Azure and a couple of Google Cloud warehouses. So I just started creating one on AWS as I was listening to Meridian. That should finish soon. But to create a warehouse, you come in here and you choose this Create Warehouse button. And when you come in here, we'll give it a name. So let's call it Webinar. We then get to choose the cloud platform. So when you engage with Actin in a purchase of Avalanche, you're buying a currency called an Avalanche unit, and that can be used on any cloud platform. We have the same price structure, regardless of the cloud platform or the region that you're in. So while Maruti pointed out the fact, and I think he went over this very quickly, but it was on the slide, and that certain regions can be more expensive than others. To simplify things, Actin has a single cost, regardless of which region or which cloud you've chosen. So let's say we're going to choose Google Cloud, right? And now we'll choose a region, and let's go with London. I lived there for 7 years. And then we choose Avalanche unit. So this is the horsepower of the warehouse that we're going to create. So I can start with something as small as a 1 AU warehouse. Now, a 1 AU warehouse is going to burn one of these Avalanche units that I'll purchase per hour of operation. Now, the next thing on here is that from a security perspective, we wanted to lock down access to the infrastructure. So we have an allow list of IP addresses. So only only connections from those allowed list of IP addresses can come into the warehouse. So if you're using tools like Looker, which are going to connect into the warehouse, you will need to add the Looker endpoints into your list here. And you can do this as individual IP addresses, or you can provide CIDR blocks of IP addresses, or we do have the ability to set up a private network link into your environment, if that makes more sense. And then the final thing on here is our idle stop. And this is a period of inactivity after which the warehouse will automatically shut down. The assumption being that you've forgotten at the end of the day to turn it off. Obviously, if you've got 24/7 business operations and you never wanted to shut down, you can set this to 0. Or if it was set to a value, it would probably just never kick in because you wouldn't have any periods of inactivity. But for things like we've got an engineering organization and a sales engineering team here that are constantly building demos and playing with Avalanche, and they don't always remember to clean up after themselves, this idle stop can save me an absolute fortune. So at this point, I would choose Create Warehouse, and now it will go off. And you remember earlier I showed you that graphic of what the architecture looked like. So it's spinning up the GKE cluster, it's setting up the various pods, and it's going off and doing its thing there. So let's look at a warehouse I've created previously. Here's one that I created yesterday. So when we come in here, what you'll see is this warehouse is running. We're using Google Cloud Storage. It's a small environment, just 1 AU. And so let's say I want to connect to that, and I want to use a tool like let's say Power BI. Well, no, that'd be rude. Right? Let's say Looker, right? So now what it'll do is it shows me here, here's the steps to connect to Looker. So the first thing I'll need to do is to download the Avalanche JDBC driver. And we've made that really simple by putting that link in here. And then we need to copy and paste our connection string. So here is the host that I'll be connecting to. I copy that to my clipboard. And now when I go into Looker, which is just timed out, perfect for the demo, right? So now when I come into Looker and I come into this environment and I want to, I'm sorry, if I come in here, and go into my connections, right? And let's say I'm playing with one of my dashboards here, and I've got the want to edit the connection for our airlines dashboard. Here I could just paste that string into Looker, and I'm ready to connect, right? The rest of that information I previously entered. But for all of the tools that we expect our customers to use with Avalanche, we've provided a very simple way to connect in here by listing out the tools. If the tool you're using is just using standard ODBC or JDBC connectivity, that's there as well. But as you're using these tools, it'll tell you, how you connect. And then down here, if you need to reference our documentation, there's a link to that. Or if you're a visual learner and you want to use the Actin Academy, which is our learning platform, you can just click on this link and visit that video in the Academy. So try to make it as simple as possible for people to get started with the technology. We've also built into Actian Avalanche a query editor, and this is intended to give you the ability to just write some simple queries. To make life simple for people that are trialing our technology, and we do offer everybody a $500 free trial, we have a data set that we've pre-populated in the warehouse, and that data set is provided by the FAA. It's flight arrival and departure information. And what you'll see here is there's a whole bunch of tables in the schema that make up that data set. If we come down to the largest table here is our on-time table. And what we'll see here is the definition of that table and how many rows of data we have within that table. So anyway, to make life simple for you, what we've done is we've provided you a list of queries that you can choose from if you want to get familiar with our version of the SQL dialect. And we're very much standards compliant. So in fact, the SQL language body is led by Carl Schendel, who's one of our talented engineers. But what we've got the ability to do in here is to review this query, then we run it. This is running against a data set of 7.2 million rows. And what you see is very quickly came back with the results set here. I'm seeing my top 50 flights with the biggest average delays. If reading is not my thing and I'd rather see this graphically, I can create a chart in here. I say I want to see a horizontal bar graph. I want to plot the airport codes versus the total arrival delay. Now I can say create the chart, and now I've got a more interesting view of the data. So just making it really simple for you guys to get started with the technology. We also have in here the ability to save this query. I can decide as I save it, do I want to share it? Is this going to be a private query that I'm not going to share across the organization? I can clone queries, so maybe I think I can improve upon this query, but I want to keep the original just in case I mess up. That's provided for right here. And then this pretty printing will actually format the query in a way that to me is more legible and provide you with keyword highlighting and so on. So this query editor, part of the platform and intended just to make it really simple for you to get started with the technology. Also built into the platform are our integrations capability. So if we start with something very simple like the desktop data loader, and this is intended if you have a CSV file sitting on your desktop, you want to load it into the warehouse. Let's make that simple. So first off we choose the warehouse we're going to load it into. We give this a name. Let's call it webinar. We then decide if the behavior for the load. Do we want to append it to an existing table, replace the existing table with the schema for this table, truncate the existing table and append this data into the schema that's been left behind. We then simply browse to the file. I'm going to choose a simple file here, and then we upload it. And at this point, what it's going to do is it's queued up this job. It started uploading the data, and in a matter of a couple of seconds, this should report back that it was successful. I love live demos. Let's hope this works for me today. Bear with me just a second here. This should have been fine. We go into our warehouse. Let's see if there's something going on here. This is Murphy's Law, right? When you're Irish, you're very much aware of the fact that when you're doing live demos, things can go wrong. I'm not exactly sure what's going wrong there, but we can maybe take a look at it in a minute. And the other thing that we can do inside our integrations is to set up more complex configurations. So if I wanted to set up an integration configuration, I can say create configuration by clicking on this button over here. I can then base this integration on an Actian template. So let's say I want to load data from maybe it's Salesforce into Avalanche on Google Cloud Platform. I will then choose the warehouse that I want to load the data into. I will then give it a name. So let's call this webinar. I'll then start the wizard. It'll then ask me for the username, password, the object name that I want to load. It will then ask me for all of this information relative to my Google Cloud Storage connection, because as you saw, we're loading this into to Google Cloud. So I would typically provide all of this information, but in the interest of time, I won't. And then in here, I can just tell it which is the table that I want to create, and by providing a name right here, and then create it. And it will go off and it will create that table, taking that data from Salesforce and loading it into that table in my Avalanche warehouse on Google Cloud. So we have a whole bunch of templates that are available to you. and those templates are intended for you to customize and to build your own integrations that meet your business needs. And then the last thing in here is our Web Connect capability, and that gives us the ability to reach into JSON sources, identify the elements of those JSON documents that we want to load into the warehouse, create a structured table, and load that data into a relational table. I know we're running out of time here, so the final thing I'll show you is when we come into Looker, that data set that I was playing with earlier relative to the flight arrival and departure information. And what you'll see here is a dashboard that we designed for that data set. It's got 7.2 million flights that it's just analyzed. And what it's identified is the number of carriers and airports, the total airtime, then our top 10 busiest airports, flight by state. I can then dig into the next level of detail here, and it will provide that next level of detail. So for a business analyst who's interested in digging into the information, you've got the ability to do all of that in here inside Looker. And when you're using Looker together with Avalanche, all of this can be achieved in real time. So I realize we've run out of time today. Really grateful for you guys joining us to learn more about Actian Avalanche on Google Cloud, and also to learn more about GKE and best practices as recommended by Google and as employed by my team to deliver this platform. If you're interested in learning more, we'd love for you to visit the Actin.com website, where you can try out a free trial of Actian Avalanche on the platform of your choosing, but we hope you choose Google Cloud. And to do that, you would simply come over here and visiting Actian.com, you can do the try Avalanche, and that will bring you into the free trial process. And the other thing that you can do is to visit our hybrid data conference happened last month. Everything is now available on demand. So if you wanted to learn more, there's some really great sessions in there, and you can learn more about the technology. So thanks again for your time today. Really appreciate it. If you'd like to stay in touch, you can reach me at emma@actian.com, or you can find me on LinkedIn. So thank you.
Thank everyone for attending.